Hi everyone, I trust you're doing well today. I hope you enjoyed the lecture yesterday and I hope you've gone through it. It is better you go through it so that you'll be able to follow up as we progress. We are going to continue today with oil injected compressors. But before I continue, I would like to do a quick recap on what we studied yesterday. We saw the different brands of compressors and we saw the basic principle of air compressor. We also learned that compressors classify as dynamic and displacement air compressors, and we saw the different air compressors and the most popular ones. We also learned that there are several brands of air compressors. Last couple and gas around Cop Air, Boogie, Su Air, Ilgi, you can't name them all. And the classification of air compressor. We saw the system, the air and oil system for air compressors, and the function of some parts of the air compressor system, like the water valve, oil separator, and all that. Well, we are going to continue today with oil injected compressor, and I would like you to pay attention. At the end of today's training, I'm going to simulate how an oil injected air compressor works. So be patient to watch to the end and do not forget to watch that video. It will give you a very good overview of what we are studying and it will make learning very much easier for you. Well, this is what we've been studying. This is just the air and oil cycle. Okay, this is basically a compressed air system showing both the oil circuit and the air circuit. Unlike the ones we saw previously, which was just the air circuit. So what happens there is that from the blue ones are the air circuits, the yellow ones are the oil circuits, the red one is the control air. The control air is what opens the unloader valve and what closes the unloader valve. Okay, so basically the control air gets a signal from the control module, and the control module will say, "Oh, come on, we need air." It will send a signal, and the solenoid will open, and it will take air from the separator to open the unloader valve. And when it should unload, the solenoid will close, and this air will be purged through the blow-off valve. So that is simply how this control air work. But then, from the atmospheric pressure, like I said, we suck air at 1 bar right through the inlet valve or unloader valve. You can call it inlet valve, you can call it unloader valve. Some call it throttle valve also, depending on the design of the compressor. So it gets compresses. And at this point, it mixes with oil and it goes through the oil separation system. The air goes and the oil go through cooling, and from cooling through filtration and get injected through the oil stop valve. This oil stop valve has a very unique role. It is the oil stop valve. We are going to see this one after the other, but just I have to mention this. The oil stop valve is what regulates the amount of oil that's in the compressor. So when this fails, you can have so much oil here that when this wants to close, whenever the unloader valve wants to close, the oil will purge through the air filter. If you go to a compressor and you see oil in the air filter, one of the things you should suspect is either the unloader valve is not closing or during unloading, or this oil stop valve is not working properly, therefore flooding this system. Or lastly, the seal here is broken. So those are the three reasons why you may see oil in the air filter. Well, let's progress. This is just what we've explained, and this is when we have double elements, two stage. Consider there are two stages here. We'll get to that much later on advanced course. Well, let's look at the bearing life. There are things that can determine the bearing life of an air compressor. It could be the size of bearing and the load the bearing carries. But basically, that is for design, so you shouldn't bother about that. What you should bother about is the quality of oil. Bearing lubrication quality matters a lot. If the oil grade is low, you buy a local oil that does not have quality, aftermarket oil, you may lose the bearing quickly. If the compressor is running on high temperature always, the oil temperature is always high, you may lose your bearing quickly. If your oil is contaminated, maybe some data gets into the oil for one reason or the other, your bearing, you may lose it so quickly. So those are all things which can cause it. I want to look at air oil separation. Air oil separation is actually very important because if your air oil separation is poor, you're going to have issues like oil carryover. What do I mean by oil carryover? In the line where you want to use the air, you see that there are oil. For example, let me use textile again. You're making textile and you're using oil injected compressor. Whereas oil carryover, you see the textile will get contaminated. Of course, for textile, it shouldn't be oil injected, it should be oil free. But some customers sometimes add filtration, they use oil injected because it's quite cheaper for them. Now, this is the air oil receiver tank. And right inside here, there's what we call the oil separator. It's actually a filter. We call it oil separator filter. Then there is another small pipe you're seeing here. This is called the scavenge line. It goes through right under the service stage, the compressor element. So it sucks out whatever oil that stay back on the oil separator. Right inside, it sucks it back through a suction um, pressure to the service stage. Okay, so that is how oil separation happens. Then look at the three steps of oil separation. First is that when this air gets into the compressed air system from this place, air and oil gets into the compressed air system, there is a pipe that has been curved. So because of that curved design of that pipe, the oil will go without force with air and it will have a cyclone motion. By that cyclone motion, it drops a greater percentage of the oil here and just a few percentage of the oil goes. And while it's going, this oil separator, the yellow thing you're seeing here is the oil separator. Will now remove those oil. You should remove it almost up to 100%. A little will now settle down here. So that little that settled down here is what will be sucked through this scavenge line back to the system. Now this is a capillary tube. So the suction force pressure it receives here helps it to suck it back. Now be aware that it's a very small tube. So if there are dirty or clunch oil in the system, what happens? It means that it will block. And once it blocks, even when your filtration is oil separate is doing its best, the little oil that stay here keep rising until the air will blow it out. So you have a lot of oil in your system. So this is important. From that, if you get an oil carryover complaint, check the separator. If the separator is okay, then check this scavenge line. The scavenge line is responsible for that. So I've explained everything about oil separation. This oil separator is usually replaced after 8,000 hours, which is sometimes 2 years, sometimes 1 year, depending on how much this machine runs. Now, oil filter. I believe every mechanical engineer who is practicing knows about oil filter. There are different kinds of oil filter. We have the cartridge type. We have this type which is inbuilt. Okay, inbuilt in the system like this. This is the threaded type, this is the cartridge type, and this is the threaded type. So, as you can see here, this one is inbuilt. Okay, it also have thermostatic bypass valve, which determines whether the compressor will go for the oil will go for cooling or not. You can see here where the thermostatic bypass valve is built in this system. So in this case, The thermostatic bypass valve is built in. There's some other ones that are just attached next, also just almost like this to the mounting for this. Well, what the oil filter does is basically to remove any contaminants which might be in the cooling system, like the aftercooler, the oil cooler, any contaminant that could go into the compressor, into the oil system. Before you re-inject it to the service stage, you first filter it. So that is the work of an oil filter. This is also thermostatic valve. We have different kinds of thermostatic valve, just like I said. This one is inbuilt here. This for Atlas Coco, this for Gasorant, this design. This is like the one we have in our car, same design. Now we have different range. I think this is 60 degree. This is hot ambient area. This is normal ambient area, just like we have, let's say Nigeria, Saudi, Nigeria, Belgium. But in the northern part of Nigeria, you can actually use 60 degrees because it's hot. While in Port Harcourt, in Lagos, you can use 30 degrees. Now, what happens exactly when you use the wrong thermostat? If you use the wrong thermostat, you may have condensation of water in the oil system. Now, the idea is that before your compressor, your hot oil goes for cooling, it should attain at least atmospheric pressure and temperature. So in a place like Nigeria, where most likely atmospheric temperature is 36, you should use 38 degrees centigrade. In a place like Saudi Arabia, where ambient temperature is up to, can even get to 52, 55, then you should think of minimum of 60 or 75 degrees centigrade thermostat. So otherwise, you're going to have condensation because the compressor will tend to overcool in relative to, if compared to the ambient condition. Okay, next is minimum pressure valve. Minimum pressure valve is mounted here on the top of the separator, and the work it does is it's ensure that certain pressure is being retained in the vessel. Why is this? For oil injector compressors, they don't have oil pump, and without an oil pump, you will not have effective circulation of oil. So for you to have effective circulation of oil to lubricate the gears, the bearings, and give the cooling, the adequate cooling, you need to keep certain pressure that will continually push this oil through the oil system. In order to do that, the minimum pressure valve is designed and introduced on top of the oil vessel. This is the oil vessel cover, which is here, and this is the minimum pressure valve. That is the same thing you see here. This is the housing. This is the spring. This spring is 4-bar tension, and it is this spring that provides the minimum pressure. Before this spring can be opened through this check valve, there is a check valve at this point. At this point, this is a check valve. For this air to push it up to allow air goes out from here to your system, you need to overcome this spring, which is 4-bar. That means that at every point in time, there must be 4-bar of air in the system. Okay, next is the scavenge line. I've already explained. See, it's colored pink to differentiate it from the rest of the oil system. Now it simply sucks this through a suction pressure that's created as this screw rotates. Okay, so this avoids oil to gather here and go out to the air. That is simply what the scavenge line does. Thermostatic valve I've already explained. It's just for what a thermostat does in the car. It allows the hot air to go for cooling. So until you attain the pressure, the temperature of the thermostatic valve is not going to open. With a 60 degrees, it means that your oil will continue to be bypassed to the system until it gets to 60 degrees. After then, it can open and go for cooling. Well, this is the aftercooler. The aftercooler is to cool the hot air before it will be sent to your system. When a compressor is compressed, the hot air gets up to, if you don't cool it, in fact, it gets to, it can continue to rise, right? Before you injected compressor, it will shut down if it exceeds 120. So around 70, 80, 90, 100, it keeps going for cooling, and it maintains about 75 to 80 degrees Celsius. So basically, this is a heat exchanger. They exchange heat with air being blown by the fan. That's the fan here. This is a water drain. After your compressor, your hot air is cooled, what happens? Some condensation will come, and it is only the electronic water drain or water drain that will remove this condensate and purge it through this place, this place, this place. It will purge it out. Now we have mechanical drain, which is this. It doesn't need electricity, it doesn't need any cable connection, just it needs an air in the header, and it will purge. Once it rises, there is a level gauge, and it gets to the level, it will purge on its own. So it is used mostly, it's not sometimes as effective as this, but it's used mostly where you cannot get electric connection. But this is an electronic water drain, EWD, and this one needs power. Sometimes it is 115, sometimes 24 volts, sometimes 220, 230 volts, depending on the design and depending on the electrical chemical they will supply what is used. And this is basically like a timer. It is being set to purge at a particular time interval, maybe every 10 seconds, every 30 seconds, every 1 minute, every 2 minutes. Mostly 1 minute, 2 minutes to purge. And it's well, this is the cooling system. You can see some new design in Alaska. They have radar fan. This radar fan is actually effective because it has high volume. Okay. There's some other system like this one in this case has the normal fan. All what they do is to blow air to the cooler, and the cooler will be able to exchange hot air, because the cooler will exchange hot air, but when it blows the air, it cools it so that it can still continue to do this exchange time and again. This the element. It is called an element. It is called an air end. It is called a service stage. So it depends on what you want to call it, whichever you remember, they are all correct. It is a screw, male and female rotor. You can see the male rotor, the female rotor. Male rotor, the female rotor always have a long edge. Okay, so these are all services. This is what compresses the air. So this is the main part of the compressor, and it is very expensive. Therefore, you must always care for your service stage. Otherwise, when you lose it, you are almost as good as buying a new compressor. Well, this is small range oil injection flow diagram. We've talked about this. You can see the labeling, the flow, air intake valve, compressor element, air oil separator vessel, oil separator, minimum pressure valve, after cooler, water separator, air receiver. Air receiver is like where you store your air. Okay. For the oil flow, you have the oil, the thermostatic bypass valve, oil cooler, oil filter, scavenge line. All these things we've explained. This is for the general working principle. Just I will do an animation on this, so no need to explain now. Um, Before I do the animation, we have a preventive maintenance plan. We expected that every day there are things you should do to your compressor. But before you anyway do any maintenance on compressor, you need to make sure you carry out certain safety precautions. When you need to stop your compressor, when you stop it, you press the emergency button. The emergency button means that once you press it, once you activate it, nobody can start the compressor until you deactivate it and reset. So this helps you when you're working. Nobody will start because the compressor can easily cut you. Okay, so that is why it is important for you to ensure that you carry out this safety precaution. Then next is, yeah, you switch off the voltage. Then you also close the outlet valve. When you close the outlet valve, it makes if another compressor is running, the pressure will not go through the system. Then you drain, you depressurize the system. These are all precautions. If you don't depressurize the system, you can lose a part and you just see that high pressure air will hit you and you can get injured. Okay, there are daily precautions, quarterly precautions, yearly precaution, and all that. I mean, yearly checks. Daily check, you should check oil level every day because you can wake up and come and there's leakage. You should check your reading on display to help you to see the pressures, the temperatures, and all that. Check if your condensate drain is working. Those are your electronic water drain or mechanical drain. Okay, and you can see if the condensate is discharging. You see it on your own. Then check your dew point for a dryer which is integrated, for a compressor which is integrated with a dryer. Some compressors have an inbuilt dryer to dry the air, while some do not have an inbuilt dryer. Every 3 months you check the cooler and you clean them if necessary, depending on the environment. Or if, on compressors that have dryer, check the condenser of your dryer and clean them if necessary. Remove your air filter element and inspect it to see if it's good, if it's bad, or if you need to clean or if you need to replace. Check the filter element of electric cabinets. The filter element of electric cabinet allows the filters dust from entering the electrical cabinet. So sometimes when it's plunged, the electrical circuit will be heating up and you will be losing your contactors. Sometimes your overload motor relay will open. Well, I didn't talk about this. I hope I find time to. Someone should remind me about the electrical circuits so I can talk about the electrical system. Overload relay, there are some protections for your system. If your motor, for example, is at risk, maybe the bearing is getting bad, the overload relay can trigger and your system will shut down. There are many other controls there I would like to talk about as we progress. Well, this is just a old type of control module. This is actually from Alaska. Every other compressor system have their own. Kesa is Sigma. Okay, I would like to show you an animation. This animation is just about how the air compressor system works. You can see suction filter. This is the suction filter. Suction valve. This is the suction valve, which is the unloader valve or your inlet valve. You can see whatever is highlighted is now this is compressor element. This is non-return valve. There is a check valve here. And this is oil separator. This is a minimum pressure valve. This is your aftercooler. Okay. So now let's look at. Let's try to see how it works. Now this is how you see air is going at atmospheric pressure. Goes through the system, get compressed. After getting compressed, it mixes with oil and it's hot. It goes through this check valve and it goes for separation. So some goes there through cyclone, whereby a little goes there and look at the scavenge line will suck. This way is very hot, going to cool. After cooling goes out through the system. The same way the oil is also hot, the oil will have to go for cooling. After cooling also goes through filtration and get reinjected into the compressor element again. So this cycle repeat time and again. So there are phases. And each of the faces, you can see each of the faces. So this will continue, and this is basically how an air compressor runs. If you have time and if you're able to read, so you can read through this, you see the faces. Well, this is where we end for today, and I hope you've learned a lot. Do not forget to subscribe to this channel. We have a lot to show you. Feel free to subscribe, share our video, share the channel link, share the video link to your friends, to your loved one, and drop your comments. Any question you have, drop your comments in the comment section and I will respond to it. You can see this compressor has built to 7 bar. This when it's on, to start building slowly. 2 bar, 3 bar, 4 bar, 6, 7, and it will unload at 7. Okay, thank you very much. I hope to receive your questions, okay? All right.